Okay, this week is Unit 7. That's the TPM implementation and process improvement tools. So what we do is in total productive maintenance, we usually use a variety of problem solving and process improvement tools because you need these tools in order for you to be able to find out what's going on in your equipment or system. So we'll be exploring benchmarking, failure modes and effect analysis, and root cause analysis. Benchmarking is nothing but just learning from each other because it's our nature to learn from others. Um, what we do here is we try to get the good practices and we avoid the practices that um, tend to be harmful. And if it is combined with good judgment, meaning like you have to try to understand which ones are bad and then which ones are good, and then you go with the good practices. Okay? That's benchmarking. So for TPM, we're going to learn from the companies that have already successfully implemented it. So we kind of get the wisdom from other practitioners in business and industries about how to improve the processes in developing the best maintenance programs from the leaders of the basic concepts of benchmarking. Okay, so benchmarking is nothing but it's just a process of searching for the best in class and learning from them. So in benchmarking, we really need a very honest self-assessment. It's kind of like you're comparing the weaknesses and strengths, okay? And you're very determined to emulate, not copying, just emulating the path that all these leaders traveled to get all the way to the top, okay? And that's what you're learning from them. So benchmarking requires a company to identify and then study the leaders in its own industry or field rather than setting for second best. And that's what I'm trying to tell you all the time. To study the company, to study their CEOs, to study their vision and mission in order for you to be able to align your goals in your life with the company goals. If you do not align them, it's really difficult for you to be able to direct yourself, where you want to go in your life. What I meant here is for your career. So some difficulty in benchmarking may arise from the fact that some companies, especially those in direct competition, they may be reluctant to share or publicize their business practices. Most of them are usually they put them confidential, and if you break that confidentiality, you will get into serious trouble. But then the affiliated organizations and companies, we always share, okay? Um, to learn these best practices. So how do we share them? You go to the trade shows, seminars, workshops, trade journals, publication, you read them again and again. Professional societies, join them, organization affiliations, and make them form them. It's kind of like a big networking. These are the major sources, again, for your network and also data. So benchmarking is not an end or a destination, rather it is a continuation and ongoing process. So that is what is meant by continuous improvement. So the purpose of benchmarking is not to determine what the best practices are, but how these best practices are achieved. Okay, this is just a blueprint for benchmarking, and in this textbook they got it from AT&T. And it's explained in 8 steps. So the very first one is conception, It's nothing but you identify which areas of the company may benefit from benchmarking and state the specific need or needs. And then you're going to plan, so state the goals and objectives for benchmarking and work out a plan. Then you're going to do data collection. So you definitely need to know your own process in order for you to be able to collect the data. Identify the best in class. So identify and select those enterprises that are known to be the best practitioners in the aspect of business. Then collecting data on best practices. So what you do here is collect detailed data on the practices of those companies that have been identified as best in class. Comparisons, so compare and evaluate your company's practices and methods with the practices of those who are best in class. Implementation, the same thing, develop and implement plans to incorporate these practices into your own operations and procedures. And the last one is evaluation. So assess your success, measure your achievements, compare them with your goals and objectives. So that's what you do in your AT&T blueprint for benchmarking. And then we have 5 pillars of total productive maintenance. So TPM is rooted in 5 clearly defined and solid principles. Pillars are nothing but the principles that we built the total productive maintenance, and we call them 5 pillars. So each pillar is an important fundamental principle, but the strong interrelationship should not be lost to the reader. So the TPM principles are: so all maintenance activities should be planned rather than reactive. You have to plan in order for you to be able to maintain your equipment and system. And that planning is very important. So planned maintenance is nothing but your all maintenance activities must be planned. Okay. Okay, the next one is your maintenance free. Maintenance free is nothing but it's just a system of thinking and practice at the concept and design stage. It's going to help create equipment that requires less maintenance. And when maintenance is required, the equipment can be brought back into operation in less time. So maintenance-free principle is nothing but we're trying to create the equipment and that requires less maintenance. Okay. So we're dealing right here at the design stage. So if we design the equipment correctly, then the equipment is not going to need a lot of maintenance. Okay, so it's just like improving the design stage so that we can go maintenance free. Alright, the next principle is individual Kaizen. Kaizen is a Japanese word and is considered the single most important concept in Japanese management philosophy, but now is used everywhere in the world in total productive maintenance, and it's just a constant search for improvement. This is just a conceptual picture or a diagram that we usually draw for the total productive maintenance. So we have this 5 principles, and I've already taught you 3 of them, and we're going to get into the next 2, and all of them are based on your quality, 5S, and safety. So the next one is your education and training. So the effectiveness of employees directly depends on their knowledge of the principles of TPM. So therefore, you have to come to the university in order for you to be able to get all of the foundations, okay, knowledge that you need to be able to build your career on it. And if your knowledge is kind of at a lower level, it's going to be really hard for you to be able to do the job. Okay, so therefore it's so important that you gain this knowledge when you are studying. And when you're studying, do not judge, okay, the subject. You have to know everything as much as you can. Not only what the professors are giving to you, you have to know more than they give you. So meaning, like, I totally recommend you to have a textbook if you decide to do a particular career. And again, you have to have your own goal in your life because we can't draw the goals for you. So you have to know exactly what you want to do in your life. If you don't know, you start to set your goals, where you want to go, what you want to do. Sit down and think about it. Okay. Once you have your clear path, you're gonna gain, try to get the knowledge that you need in that path only. You don't have to get all the knowledge of the world at all, okay? And you will make your expertise in the line that you have chosen going towards your goal in your life. And so going back here, the principles of TPM, knowledge is important. That's why we do education and training, so that you have understanding of your equipment and your system and your processes so you can maintain it. Okay. Self-maintenance, this refers to a basic program of maintenance activities that are performed by the operator. Okay, so these are all the 5 TPM principles that we use in total productive maintenance. This is just showing you a variation of TPM pillars. Okay, all textbook we have only 5, but for other people they go like 1, 2, 3, 4, 5, 6, 7 of them here. Okay, so that is one thing that I'm trying to tell you, that we have a lot of variations in the United States, even in the theoreticals or principles. Okay, so just go with the flow with your own company that you will be working with. The next thing about your life goal is most of you just want to get money and get a good job. That's not very sufficient. Okay, so if you're in that group, make sure you try to analyze yourself, try to know yourself, what you truly want, because money is not the only thing in the world that is important. It is important, but it's not the thing that is important. You're like, as you grow older and older, you will see it. Okay, I can't teach you that. That's a life thing, and we all have a different lights, and you have to learn between you and God's and the environment. Okay, so but the recommendation is better to have a clear goal with a specific career that you want to move on. Okay, and you have to choose that as early in your life as possible. Okay, that's just an advice. Do it or not, that's your choice. Okay, the 5S. The 5S is the foundation that these pillars are based upon. So the pillar rests on the concepts of quality. 5S in safety. We know the quality, we know the safety. So 5S is just a concept and used to describe what proper housekeeping and organization means, because it's so important, especially in manufacturing, maintenance system, equipment. You definitely need housekeeping or organization because it really they really make difference. Okay, the operation efficiency, process efficiency, all of them are usually based on this housekeeping or organization, by the way, and productivity. Okay, so especially the 5S described again on Japanese philosophy of workplace organization, which is widely used in the whole world, and we refer that as a seiri, and that's just the American way, or the way that we say in Japan is a seiri. Okay, and I'm from Japan. I come from a little town called Saitama because my father is a Japanese, and that's about like a 45-minute by yellow line. It's just a subway. from Tokyo all the way to the north. It's just a little town called Hatoyama. We have like a new town and an old town. So we're up on the little mountain. There's only one supermarket right up there. It's pretty quiet town. I love quiet places. So anyway, so Seitan is organization, proper housekeeping. Seisho is your sweeping and your workplace hygiene. And Seikatsu is your neatness and cleaning. And Shitsuke is your strictness and discipline. Okay. Um, Not all Japanese are clean, but most of them are pretty. They're very clean and they're very good at with handcrafts. I don't know how to say it. It's just not like being a perfection or anything. It's just that because of the country we were in is kind of like small and we don't have enough room. Okay, don't have wise places like here in America, so everything got to be organized. Okay, and the workplace got to be extremely organized in order for us to be able to consider the spaces. Okay, so we don't have a lot of land and only have three main parts of the islands, and the island is totally on the line of the volcano, yes, under the ocean. So it's kind of a very risky place for all of us to live in Japan. So we have to be so um, organized, yeah, to do almost everything, especially the businesses and factories got to be, they have very limited okay, space. So therefore, all of these principles, the 5S's, all the companies manufacturing so many things, okay, and distributing all over the world is based on this principle, 5S principle, and it really works. So now it's adopted by the entire world. So again, you can study that. Okay, so now you know what 5S is. Okay, the 8 pillars of maintenance is we're not going to go into details. I don't know why I talked to why. I just want you to learn all the only 8 of them. Okay, so again, it looks like the pillars, and there are 8 of them. And again, the foundation is your 5S. So the very first one is your support and guidance for operator sub-maintenance activity. Second one is your reduction of breakdowns and initiate activities to achieve the 0 failures. We want 0 failures. Okay, very similar to your lean okay manufacturing. So anyway, planned maintenance activities, review the existing preventive maintenance program, and we have lubrication management set up programs for lubrication. And the fifth one is the spare part management. Okay, manage the spare parts inventory for planned not breakdown maintenance. Maintenance cost management. Establish a maintenance cost management system to track and control the overall budget. And the next one is your maintenance efficiency improvement. Analyze the current maintenance system. And then we have the last one is your training, enhanced training of all operators. Okay, we're very heavy on training. A lot of the Japanese concepts are heavy on education training, and if you ever get hired in Japan, you will never get fired out. They do not believe in firing anybody out. They believe in training a person. So one employee will work at the same company for many, many, many years in Japan. So that's the way that it's also very stressful because you really, really have to work, okay, and or a lot of overtime. You can reach, okay, everybody in Japan can be able to eat well and live well, and living standard is really high over there. Because you have to pay about like $45 per day, okay, just for parking, and commuting is cost about like $25 to $35 per day. So you're spending about $200 to $300 per day just for living. So anyway, so it's very, very stressful to work in Japan, but then you earn a lot of money. So if you guys have interest in work outside, you should also look into international, okay, industries which are linked to the United States. is very good opportunity for especially for men. Okay, so failure mode and effect analysis. So one such procedure involves understanding potential failure. You have to understand the potential failures and the consequences of these potential failures on your system and equipment and the overall operation system. Okay. So another tool is used to determine the underlying cause of failure so that the root causes, but the symptoms are corrected. So the purpose, now we call this FMEA. It's called the failure mode and effect analysis. So that's just we use to identify again the potential failures because we really need to understand the potential failure in maintenance. So we use heavily KFMEA. So we have 4 general types. So your design, application, process, and service. You can go any order you want: design, process, application, service, the same thing. So the very first one is your design FMEA. That's your design of product. We're going to focus on the potential failure modes, okay, due to engineering, design, blunders, or inadequacies. So it's just trying to find the design flaws, involving maintenance and operation personnel during the design process to eliminate a host of future and potential failures. So we do that in order to get rid of the future and potential failures. So the concept of design for maintainability is concerned with building into the equipment or product, okay, those features that eliminate, reduce, and simplify maintenance needs and procedures. So anyway, design is we're just focusing on the potential failure, and then we're looking at the design flaws. Okay, process FMEA. So here we attempt to identify again the steps and the procedures and processes required in performing the task so that we cause failure and assess the effect of these failures. Again, studying the process, trying to identify the steps, okay, that is going to be required, performing the task, and these tasks are going to cause the failures. So what we're trying to do is again trying to understand the potential failure in these processes. Categories, the next one, application FMEA is you're going to identify again the potential failure or risk associated with the use or application this time because we're in application FMEA of your end product. So those risks associated with the customer is a concern, okay, of application FMEA. So service FMEA is an attempt to identify potential failure modes of a service activity, their consequences, and then to provide the subsequent corrective actions, okay. So that's your service FMEA. Again, we're hitting the potential failures. Okay, so here's an example of maintenance activity. So most of the maintenance activity involve lubrication. So this little question is asking you what are the potential failures associated with this activity, which is lubrication. So they are failure to lubricate, you forget to lubricate it. Like you didn't do oil change, okay, for your car for months. You have to do every 3 to 5,000 miles, okay. It depends on your car engine, and make sure you know these things are from your manual, okay. Usually it's in your dashboard, and you do a lot of lubrications, over lubricated. That's wrong, and also the wrong grade of lubricant. You bought the wrong lubricant, okay, for your equipment. Okay, so the history of FMEA is actually rooted in the aerospace industry. Okay, industrial technology closely work with aerospace engineering and industries because you will be getting into that line in order for you to do maintenance. Okay, so that started from like way from 1960, so way before you were born, especially in the Apollo program. Performing a service of FMEA. So service is like in this column. So we're getting into the FMEA tables, and in this column for service, you're going to write an exact description of the service or the task, as it currently is, not as it should or could be in clear and concise terms. I'm just trying to tell you to write what's going on right now, okay, for your in your service column. The potential failure mode is for each service stated. You're gonna write the potential failure mode, okay, must be listed. So we'll start building the FMEA chart or table you can call it. So there could be more than one failure mode for each service function. So to clearly understand what potential failure mode means, think of what would happen if this service were not performed or performed in a correct way. So that's what you always have to think when you are building FMEA. Alright, the next one is your potential effects of failure. So the entries in this column attempt to predict the effect of failure of your service, okay, or the consequences of the failure. The historical data and past experiences are a good source of information to answer these questions and provide entries for this column. So that's for potential effects of failure. And this category is probably the most important aspect of your analysis. So determining what caused the failure is necessary so that it can be eliminated. Okay, we have to know what is causing that failure in order for you to be able to maintain or eliminate it or fix it. And its recurrence can also can be avoided. If you have a recurrence, that's not good on you because you can't find the issue, okay, and you are maybe fixing the wrong thing. So we don't want recurrence. People get fired up because of this issue. Okay, so make sure when you get into maintenance line, if you choose to go into that line, that you know your equipment, you know your system before you ever start to maintain it. So you definitely need to raise your knowledge about equipment and system that you will be working on. That's the very first thing. Okay, if you don't know it, you can't be able to fix it. So you really have to know the system in order for you to be able to fix it. So keep in mind that there may be more than one cause for a potential failure mode. So here just a simple form for conducting a service FME. So you put your name here, blah blah blah. And then this is a table that we're talking about, and we fill the service column, potential failure mode, potential effects of failure, and then we're gonna go one by one, okay? Alright, the next one is your occurrence, this OCC column in your previous table. So the OCC column is nothing but your occurrence column, and it's going to provide you the information about the expected frequency, okay, of each failure because of each given cause. So you are going to put your occurrences. It's kind of like the when you look at the occurrence rating, you're going to see say 1 all the way to 10, and then you can see the effect from remote all the way to extremely high, okay. And you can break it down into like this before you put your OCC into the first table in your previous slide. Okay, severity is nothing but you're determining, or rating the seriousness of the effect of your failure. Okay, your failure means your equipment failure on the system. So customer and all the environment. We always think about our system. Your system is always with somebody. We are talking about internal customer and external customer here. Okay, internals are those who you work with around the system. Externals are those outside of that system, and the environment is the immediate environment the system is in. Okay, we're always in an environment anyway. Your system and you are in a environment, and never ever forget that your environment is constantly changing. Okay, they're not the same. Environment is always different. Things that you can't be able to see that affects your machine, okay, especially your vibrations and your material surfaces, so all that. So severity can be categorized based on a critical rating. Okay, so now we're going to take a look at your criticality rating for your severity. So here in severity, we also consider the criticality. This is just showing the rating for the severity, which is not from your text but from outside that we commonly use. And criticality 1 is such failures may result in loss of human lives. It's very critical, okay? So we put the top priority because it involves the loss of human life, serious injury, significant loss of function, or a combination of such catastrophes. Okay, so that's go into your criticality 1. Criticality 2, it's just failure may result in a significant loss of function or a major portion of the facility. So these failures are critical. So anyways, a criticality 2 is a failure may result in a significant loss, okay, of function or a major portion of the facility, and these failures are critical. Criticality 3, so such failures may result in minor damages, and then these failures are minor. Criticality 4, so failures in this category are significant in nature and they do not impact the system, so they tend to be more if a nuisance or an annoyance can happen. This is just showing you in table 7.2 your FMEA severity evaluation criteria, and I cut the very first two to show you what it's like. I'm not going to go through the entire thing, and you can read it in your handout for the whole thing. So hazardous without warning, you're going to have your customer effect is this, the very high severity ranking. So when a potential failure mode affects safe vehicle operation and or involves non-compliance with government regulation without warning. Okay. Manufacturing assembly effects is or may endanger operator machine or assembly without warning. And your ranking is 10 because the hazards is really great. Okay. So hazards with warning. This one is without warning. It's a very high severity ranking when a potential failure will affect safe vehicle operation and or involves non-compliance with government regulation without warning, or may endanger operator machine or assembly with warning. So that's all 9. Okay, ranking 9. So you have all the way from here very high, and then go down all the way to very minor and none. So when you look at the very minor, you can see like fit and finish, squeeze, and rattle item does not conform. So the failure is kind of getting smaller. Yeah, defect noticed by discriminating customers, so less than 25%, or a portion less than 100% of the product may have to be reworked with no scrap online but in station. Okay, this is just an assembly line, okay, not the internet online. But anyway, so all of that in your ranking is 2 because the danger is not very minor. Now, none is for no, okay, discernible effect. We don't see any kind of discernible effect or slight inconvenience or operation or operator or no effect. Okay, so that goes ranking 1. Okay, the next thing is your detection. So how are we going to detect the failure? So detection refers to ability to detect the failure before it can adversely affect the system, or in the case of the service FMEA, okay, before the failure to reach the customer. So you're going to brainstorm efforts by the FMEA team. Okay, they're going to concentrate on determining how and how quickly the failure can be discovered and recognized. Yeah. So this is again your rating scale. That is your outside. And this is our textbook 7.3. You can see your detection right here. So almost impossible detection. And we put it in the criteria absolutely certainty of non-detection. Inspection type, we go with ABC and just go C, okay? That just, you don't need to pay attention for that. That depends on the company, okay? Suggested range of detection methods cannot detect or is not checked, and your ranking is 10. Then we have very remote, and very low detection. So very low detection is controls have poor chance of detection and suggested range of detection methods control is achieved with double visual inspection only. Okay, so we're doing on just the visual inspection, and your ranking is 7. This one, so make sure you read the entire table on table 7.3. performing a service FMEA, so we're going to continue RPN. We call that the risk priority number. So RPN is calculated by multiplying the three rating values of occurrence, severity, and detection, recommended action unless specific recommendations, course of action are stated. The FMEA is an exercise. In fertility, the objectives of FMEA are to investigate and cover again potential failure mode. And we're trying to find the potential failure modes. We determine their effect, and then we're going to recommend course of action, to avert the failures. The action taken, so this action is for follow-up purposes, a detailed description and explanation of the corrective actions recommended by the FMEA team should be provided to ensure that follow-up actions were taken to remedy and eliminate potential failure modes. And so those are the actions taken. So my PhD dissertation research is completely on FMEA, and we're trying to analyze the maintenance part. And we study the conventional vehicles, and also we study the electric vehicles data, and we compare them. So that's what I do. And heavily again, every time we analyze equipment like cars, planes, trains, ships, we always have to use this to be able to find the potential failure. We have to know the potential failure before the failure ever happened, so you can protect your equipment. Your equipment can be cars, it's just again try to see the equipment as a system. All the vehicles that are running and doing the transportations in the world, we're going with this FMEA to maintain them so that you won't get a chaotic stuff on the road. By performing a service FMEA is a dynamic process. So as is any manufacturing or service environment in which the FMEA activity is performed. It is a process that does not remain constant and static. So once an FMEA activity has been conducted and corrective actions have been taken, further studies are necessary. So what we do is we evaluate the effectiveness of the previous recommendation and the subsequent actions. We always have to do that for us to be able to find our failures. So it's a continuous improvement process. And again, why do we have to do it again and again? Is because the environment changes and they affect our equipment and the systems, especially environments. Never ever forget environments include the people inside. And you will study figure sum 4, and just in the handout, and it's just showing you the FMEA process sequence. This is from the outside. Outside, many different companies use their own way of forming the sequence, and here is that they're using kind of like a flow chart here. The root cause analysis is a systematic approach, and again, what are we trying to do? We're going to identify the basic or the root cause again of your problem or undesirable condition or the undesirable condition or problems. So the actions may be taken to eliminate the cause and prevent the occurrence of the undesirable event. We're trying to get rid of them. So after a problem or undesirable event has occurred, root cause analysis is used, and we're going to use it to identify the most basic factor that may have caused or contributed to the situation. Another important consideration in root cause analysis is the realization that although many causes can be identified initially, for all practical purposes, there's only one very few reasonable cause, and very few feasible solutions available. Root cause analysis. The root cause must be of such nature that reasonable actions can be taken to eliminate the root cause and prevent the problem from happening again. What it's trying to tell you is it has to be a manageable problem, if a problem is so big and you can't manage, like the explosion of Fukushima, okay, nuclear plant, that kind of problem is just you can't do, okay? And you can't find the root cause either, even if you can still find it, but then you cannot be able to prevent because it's an explosion, okay, caused by factor like the environment factor, like tsunami, okay, hurricane, things that you men cannot be able to control come from weather, okay, real big disturbances like that. So at that time, even if we know the root causes, it's difficult, okay, for you to be able to prevent it. So therefore, it's got to be such a nature that reasonable action can be taken to eliminate the root cause, okay, and prevent the problem from happening again. Something that you can control that we're talking about. So root cause analysis applies in either a reactive situation to discover the cause of the problem at hand, or in a proactive setting to predict the potential contributing causes to future adverse events. Can significantly improve manufacturing and service system performance and reliability. So in other words, what we're trying to say is if we do the root cause analysis, we can be able to understand, okay, how the problems happen so that we can be able to improve our system performance and reliability. Okay, the process of root cause analysis, the first step in the process is your problem again identification. Every time we do the problem analysis, we always identify what the problem is. If you don't know the problem, you cannot be able to fix it. Okay, so you definitely need to know your problem. And we're going to define it. So in most manufacturing and business settings, finding a problem is to solve, okay? And it's not very difficult at all, okay? You will get a habit of doing it every day. The problem definition, define the problem is the most important step after problem selection. So one cannot determine why that's your root cause, something happened, unless one can clearly define the state of what the problem is. Okay, so you have to know the problem in order for you to be able to define. Okay, data collection. The next thing that we do, okay, is data collection. So next to human resources, okay, pertinent data is the access to very valuable to organizations. So the emphasis is on pertinent because if the collected data is not relevant, okay, not good, the information could be wasteful, expensive, and quite misleading, like your COVID data last year, because it comes from many different sources and also come from the nurses in the hospital environment don't know what to do because they have the very first experience handling this virus, so they're kind of like mixed up with the other, okay, like flu or common cold, allergies, okay, kind of symptoms, but they're very similar, okay. The only thing that's different is like it's really fast and it attacks your respiratory system really fast. So then when you cannot be able to identify what's going on, then you will get into a bad data, which is not relevant, and you will get a lot of bias in your data collection, okay. So that's what happened last year in the pandemic. So data is not it's real, but then it's not judged correctly. So therefore, there is a big inflation of data right in there. So anyway, so information could be wasteful, expensive. Also, the most dangerous thing is could be quite misleading. So therefore, you have to collect your data in a very in a good way, in a right way, in a non-biased way. Okay. So techniques for root cause analysis. So the techniques for root cause analysis range from a simple unstructured process to more complex analytical methods. So this is a problem-solving process. So the first one that we do is a common sense approach. So the approach is less structured because we're dealing with common sense, but just as valid as another method of root cause analysis. Common sense is nothing but things that commonly happen. So therefore you have common sense to things that happen often. Okay, so it relies on the common sense experience and act for doing the work of the individual team members. But then these are not facts, by the way. These are your opinions and based on your experience. Okay, they may be right, but you cannot be able to take it as facts. Okay, so change analysis of the technique for root cause analysis that may be best suited for troubleshooting assumes that a change is a process, material, procedure, and so on must have occurred to cause the problem. So this technique attempts to look for a change in various factors, okay, that might influence the process or the equipment. So any change in material, procedures, methods, tooling, human factors, and the environment can adversely affect the equipment or process. So this is just telling you, or you have to be aware of the changes. So any change, um, you have to be always paying attention for what's the change. Okay, today, what's the change? Yesterday, what's going to be the change tomorrow? And pay attention to the material, procedure, methods, tooling, human factors, and the environment. Okay, and bad managers, they don't pay attention to, they're just going with the flow, okay, and don't really do anything that they're supposed to be doing, okay, and they're just surviving with interpersonal skills, be okay with other people, and write on the things that's been done by their predecessors, okay, so. And there are also those kind of managers who actually didn't do anything on their hand and just use the historic data. I don't want you to be those kind of managers. Okay, you are a university student. You will have your university degree, and you will definitely use the knowledge that you have gathered. Okay, and because it's very different if you're managing a system with how you think, with whatever, okay, or you're managing the system, what you're supposed to be doing, okay, by using the technique and the tools. There's a big difference right there. Okay? You can joke around, but over time you cannot joke around, okay. However, they're lucky people who are just writing on other people and the systems, okay, just like that, okay, making their life without really working, okay, just putting blame on other people and keep moving their life and hurt everybody on the way. They're also those kind of people. You will see them, okay, you will see them when you get into the work, and there are many different kinds of people you will come across in your life at your work, and don't be like that, okay. I want you to keep the same principle that you're doing here as a student, and you're going to apply that principle when you work, meaning you have to study, you have to know, okay, the techniques and the tools and the principles, theories, okay, and you will follow the same procedure that you learned from your book, okay, and apply it. Okay, the application of your knowledge is so important. Um, and you will see the difference. Okay. Events and cause factors analysis. So events refers to incidents, system failures, other simple occurrences. Your casual factors are contributing variables or features, okay, that have caused the event to occur or have contributed to its occurrence. So events and cause effect analysis is nothing but just again systematic approach. And I want you to apply these approaches when you actually do your work instead of just going whatever. So used to determine these events, their sequences, and the conditions under which the events occurred, and any factors that may resulted in or caused that event. Okay, that's what we do in events and causal factors analysis. So here you can see an event and causal factors diagram. So you have event 1, event 2, And here in the bubbles, your conditions leading to each event. This is just a simple diagram. Okay, so how we do the breakdown and how we study it. Okay, now we're going to fill it up. So a simple example, you can see our event is excessive grease built up on bearings. Okay, and then we have the bearing fails. No cashier, that's insufficient maintenance, record keeping, no lubrication record on file, lack of operator training. Okay, therefore you've got this. Okay, this side you have overload and you have lack of inspection and cleaning, therefore it fails. Yeah, so this is going to also contribute to bearing fails. Okay, so 7HC is just a detailed example. Again, your events and causal factors diagram. You can read it in your handout. Okay, I'm not going to go over it, but now you have an idea of how we put the event and how we consider the factors, and then how we see, how they are contributing to each other. Okay. Ishikawa diagrams. Ishikawa diagram, well, they're named for Kaoru Ishikawa, another Japanese pioneer. So Japanese pioneers used in the United States as well, because we have a heavy manufacturing factories over there. Okay, and they tend to do, they always do, to be the first class. So if you go into the Japanese manufacturing companies, you're going to see it very different from the Chinese manufacturing company. However, I can say this today because the Chinese companies also are following the Japanese methods, thanks to the international students who study abroad, okay, in Japan. They're going to build the Shinkansen. So all these students, they study the Japanese Shinkansen, okay, which is a bullet train that ran from the entire Japan. So now they got all the methods that these students study, and now these students are now the leaders in China. So they're now going to make this bullet train, okay, on the Silk Route from China all the way to Europe. So that's a very big project that they're trying to accomplish, okay. Again, if you guys want to go abroad to grab the jobs, they definitely hire Americans because you will get really paid, and usually you don't have to pay for your housing and things like that. So anyway, you can get into be alert. You can be alert, and you can also get into those kind of jobs. Okay, if you guys like to go abroad, I like to go abroad, but then I also like teaching. So my first job, I went to South Korea with a teaching, and I started teaching at the international high school actually, from 9th grade all the way to 9, 10, 11, 12. Yeah. But then South Korea is really good. The food is very phenomenal, and I love all South Korean stuff. So anyway, so if you like to, take a gap year between your graduate study and your undergrad degree, you can also do those kind of jobs. Okay? That will give you a life changing experience for you. Okay, to be in other people's country and to actually live there more than okay. I did like 1 year contract, so that way it's you can learn. You can easily learn their language. You can also learn their culture, and then you can learn about the country as well. Whatever it's the technology that they're trying to accomplish. Okay, so going back here, so they're used to represent a relationship, okay, between an event and its causal factors again. So hence are known as cause and effect diagram. So the diagram is also referred to as a fishbone diagram because it looks like a fishbone, yeah? Okay, so here in this picture, you can see just a cause and effect diagram. Here is a cause, here's another cause, another cause, and they're going to be contributing to this problem and giving this effect, okay? And you can also break down for this cause, you have a contributing factor, another contributing factor, okay? Now we're going to see an example, just a hypothetical system failure. So you have your environment, equipment, material, personal, temperature, humidity. So come from environment. poor maintenance, tooling, your equipment or system, material stock out, poor quality for your material, your personal training, lack of empowerment attitude, okay? So these are your personal. And therefore you've got your system failure. Fault tree analysis is another problem-solving technique. So like the cause and effect diagram, fault tree analysis, as they mention, or conditional requirements, among the contributing factors and shows the requisite conditions under which an event might take place. And so here in fault tree analysis, we're emphasizing on the conditional requirements, okay, and then all those factors. Although an array of symbols is available for constructing a fault tree, the most system can be defined easily and clearly with the use of three basic symbols: rectangles, then we have or gates, then we have AND, which is AND gates. Okay, so that's how we do this fault tree analysis. So here we're going to see OR gate. So here we're going to start call will not start. So we're going to start drawing our fault tree, why this fault is happening. So call will not start, or we have either startup malfunction, okay? Therefore your call won't start. Or we might have weather so cold like in Montana. Sometimes you can't start the car, okay, because the weather is too cold. So your engine needs more energy to pump it. And here is your AND gate, okay? So car will not stop. It won't stop. Why? So you think about it, it could be the main brake fails. It could be your emergency brake fails. Therefore, it won't stop even if you're pushing your brake. Okay, even if you try to pull your emergency brake, it won't stop because something's going on, yeah? Fault tree analysis. So during this design stages, a fault tree analysis can bring to light, okay, any process or product shortcomings. So we're just trying to understand a process or product and their shortcomings. Okay, and that's in your design stage. It's going to help with the design review process, and we're going to eliminate any potential for future failure. Okay. So more elaborate fault tree structures can make use of historical reliability studies to determine the statistical probability associated with each condition or factor. Again, we're dealing with the condition factors. So here's another example. So car does not start or gate. It's going to give one of the three: battery or starter, or you have no fuel. So if your car doesn't start, you're going to start to check your battery, check your starter, and check your fuel. Okay. Now I'm going to come deeper into battery. Let's check your terminal. Is it corroded? Clean it. Cables broken, loose, corroded. Okay. Check all if they're tampered with or not. Battery, is it old? Okay. Check the life of the battery. And you're going to check your whether it's too cold or not. Now starter. You're going to check defective solenoid. Usually solenoid is for your starter. Bad one, okay, bad solenoid. You won't start. And then starter motor failure, okay. Fuel. You're going to check your fuel tank. Is it empty? You're going to check your fuel filter. Is it clogged? And then you're going to check your fuel pump. Is it defective? Okay. So check all of that. Check, check, check. So that's how we do the fault tree analysis. Implementation of solutions. The most important input into the root cause analysis is your problem identification. Okay, what's going on? Why am I getting this? Oh, it's because of that. The most important output of root cause analysis is to devise a solution or solutions that will remove the hazard, resolve the problem, and ideally prevent its future occurrence. Okay. Alternative solutions. Although long-term solutions are obviously preferable, we always hit the long-term, but sometimes they may require a longer period to implement, so we will do alternative solutions. So if time and resources are not available, a short-term solution, temporary fix might be necessary, okay, to deal with the problem at hand. So as with the statement of the problem, each solution should be again clearly defined in terms of its scope, goals, objectives, attributes. and the various metrics and measures that are going to be used for its evaluation. Evaluating alternative solutions. Various methods can be used to evaluate alternative solutions. So lab tests, you can use that. The use of prototypes, you can use that. They're going to allow experimentation with physical and tangible models. Sophisticated, advanced software programs, you can use that. Okay, they're going to make the use of computer simulation modeling for evaluating alternative solutions a viable technique. Mathematical and statistical models can not only enable us to visualize the different production scenarios clearly and quantitatively, okay, but they also serve as a powerful tool in evaluating various alternatives. So the operating personnel, the team, or the employees, and the customers who are expected to be involved in the implementation of the solution or are affected by the solution must be an integral part of the solution. Okay, so that's how we evaluate alternative solutions. Okay, so this is the end for your chapter. This is unit 7.